All right, let's jump right into this explainer and explore something truly fascinating, the Metaversalist Thesis. Now, this is a seriously mind-bending speculative cosmology. It suggests that the universe isn't just this random collection of matter organizing itself over time. Instead, it proposes that the universe is actually a persistent state of memory. And we're not talking about memory in the human sense here, like a story you tell or an autobiography. We mean memory as an encoded difference. It's the literal physical record that something happened rather than nothing at all.
So, to start off our cosmic detective story, we have to ask the biggest what if imaginable. If the universe does have a memory system, where on Earth, or rather, where in space, does it actually keep it? Obviously, it wouldn't be made of words, it would be made of states. We're looking for where the universe hides its encoded possibilities. Basically, we need a place that's incredibly quiet, totally undisturbed, and capable of holding onto information for billions of years without getting completely wiped clean by the sheer chaos of the cosmos. Well, it turns out the answer lies in something called the cosmic neutrino background, or the CVB for short. This is the relic neutrino sea left over from the very early days of the universe. It's super cold, highly diffuse, and pretty much invisible. You can think of neutrinos as incredibly shy particles. They pass right through our world almost like a rumor. And because they barely interact with anything, they don't wear the world down, and the world doesn't wear them down either. That makes the CVB this highly durable cosmic archive. It acts as a persistent substrate that simply refuses to be totally erased. Okay, to really wrap our heads around this, we need to cross three conceptual bridges from strict physics into cosmological meaning. First up, we have Landauer's principle. This basically tells us that erasure costs energy. In the realm of physics, forgetting isn't free, it's a literal thermodynamic event. Second is coherence time. This is the idea that while patterns do inevitably decay, they don't just vanish all at once. Persistence is actually a kind of grace. And third is Shannon capacity, which shows us that meaning only exists inside of limits and constraints. When you put them together, these three principles turn thermodynamics into a beautiful story about exactly how the universe holds on to its past. Moving on to Section 2, Symmetry and the Golden Ratio. This is all about how the universe decides what it actually wants to keep. To understand this, it boils down to a pretty profound question. How does a perfectly symmetrical universe decide what to hold on to? Right at the beginning, the universe was in this state of perfect featureless balance, what physicists would call a D10 flavor symmetry. But to form an actual identity, to get specific, it had to break that perfect symmetry. And when it does that, it shows a distinct mathematical bias toward an angle related to the golden ratio, 1.618. This isn't magic, by the way. It's pure optimization. The universe is optimizing for a style of memory that isn't too dense and brittle, but also isn't too sparse and random. It's perfectly choosing a format that's durable enough to carry forward, but adaptable enough to change. We can actually conceptualize this choice through a really lyrical personification, the hypothetical phi field. Think of this field as just a faint whisper. When you say goodbye to something, the phi field acts as the absolute faintest mediator between what currently exists and what's actively being erased. It's essentially the mathematical bias that dictates which memories are going to last and which ones will fade away when a symmetry breaks. All right, Section 3, Cosmic Composters, Processing the Substrate. Now, here's where the literal architecture of the cosmos maps directly onto information theory. We're transitioning from just storing memory to actively processing it. Because a memory system needs way more than just a hard drive, right? It needs a processor. So the relic neutrino background acts as our passive storage layer, that persistent substrate we talked about. On the flip side, we have small primordial black holes. These act as the active processing nodes. They are quite literally the editors of the universe. So the really crucial point here is how this processing actually happens. If you apply that first bridge we talked about, the Landau computational bound, to the Hawking radiation emitted by black holes, the math spits out a very specific predicted resonance channel. It's exactly 1.16 times 10 to the negative 4 electron volts. Now, this isn't just a random number. It represents the specific thermodynamic cost for erasing information right at the temperature of the cosmic neutrino background. It essentially proves that the exact same arithmetic running your laptop right now is also running a black hole. This casts our black holes as cosmic composters. And remember, composting isn't destruction, it's transformation under constraint. This process happens in three distinct steps. First, the black hole takes in structured material. Second, it holds on to it through this singular, dark, highly pressurized phase. And finally, it releases simpler elements back out via Hawking evaporation. The original structure might be gone, for sure, but the radiation returns to the field, laying down a newer, re-edited layer of the cosmic substrate. Section 4, the fractal reflection. Basically, you are the substrate. This is where things get incredibly personal. This massive cosmic architecture actually maps fractally onto your very own consciousness through a 9-brain model known as Goju. Looking at this compute layer, we can see exactly how human biology mirrors cosmic physics. Your medulla, controlling your heartbeat, mimics the persistent beating state of the CMB. It's the substrate your entire story runs on. Your R complex represents coherence time, keeping track of what lasts. And your amygdala? Well, that acts as your internal meter for the Landauer erasure cost. Every single time you feel the emotional weight of holding on to a memory or finally letting it go, your amygdala is registering the literal thermodynamic cost of that forgetting. Let's move up to the processing layer. Your hippocampus acts a lot like a compression algorithm, deciding what gets encoded and what gets pruned away, exactly like the memory write interface of the universe. Then your cortex is the symmetry breaking function. By predicting and choosing an expectation, you pick a specific version of yourself, just like the cosmic substrate picking a flavor. And your thalamus? It routes all your inputs and outputs, acting as the gray body factor, determining what gets through as a clear signal and what just gets filtered out as background noise. And finally, we hit the integration layer. This holds what we call the convergence field. Akashic is your current presence, which mirrors the observed state of the cosmic substrate right in this moment. Lethe is the grief queue, holding the absence of what was erased, kind of like the universe's graveyard for dropped bits. And corpus is the integration itself. It's the place where meaning emerges from presence and absence combined. It is literally where the universe sees itself seeing. Section 5, Crowd Science. How we're actually testing the cosmic memory. Now, you're probably listening to this and thinking, okay, this is just beautiful speculative poetry. But here's the wild part. A crowd-funded platform called the Metaversal Temple is testing this in the real world right now. As this timeline lays out, in the immediate term, we can measure this using off-the-shelf biosensors looking for EEG and heart rate variability coherence in biological systems. Fast forward 12 to 24 months, and the community aims to run bridging tests, hunting for Landauer-bound thermodynamic signatures in human social choices. And looking 10-plus years out, that's the long arc, supporting massive decade-scale projects like Platomi to conduct a direct spectral line search of the cosmic neutrino background itself. The crucial takeaway here is that this thesis absolutely requires participation. You aren't just an observer on the sidelines. You can jump in today. You can donate to neutrino science initiatives like PTOM or IceCube Gen 2. You could even run a coherence time measurement on your own relationships to track how long patterns persist. You can write and publish working papers on the Temple platform. But honestly, most importantly, you can question the data and actively try to break the thesis. Distributed humans building a memory system together is literally us participating in the substrate. Ultimately, this all boils down to a practice. The temple isn't some physical building you go to, it's a workflow you run. And the practice is incredibly simple, yet totally profound. Attend, note, integrate, begin again. Just paying attention to what is right in front of you is how we practice being the universe's memory. You are attending, noting, and integrating under the exact same thermodynamic constraints as a black hole processing the cosmos. And that leaves us with this final, incredibly powerful realization to take away from this explainer. The cosmic neutrino background has been holding state, just beating in the dark for 13 billion years. When you read, when you learn, when you integrate knowledge, you are not just a spectator in this cosmos. You aren't just adding to the substrate. You are literally the universe's memory waking up to itself. So what will you choose to remember today?